Okay, so this was the whole coffee shop model where we talked about client server computing. This is, right? So just talking about how, we go into a shop and we make requests, right, to a barista. We say, hey, can I have coffee? They say, yes, wait a second. And then they give it to us. And that's the whole client server model. This is basically how AWS works, although there's three different kind of vehicles for this. There's the web console, which is like a website, just like the websites that we know and love. There's the command line, which is like you're on the little green screens typing stuff. And then there's programming, which involves knowing a coding language. And so it all gets really weird after that. But mainly we're going to do most of our stuff in the web page because that's actually the easiest way to learn, because we're very, we're multifaceted, but we're visual creatures. So we're going to stick with that. So the client server model basically says, hi, I would like a virtual machine. And then it says, okay, I'm spinning up a virtual machine. So that's the sending the request and then you get a response. So it's request response also. So we talked about, like how AWS thinks about cloud computing in terms of like, only paying for what you use, which is on the far right, accessing services on demand, avoid having to invest in large pieces of hardware. So this is why cloud computing is so attractive, is because instead of having to like buy large servers and wait 6 to 8 weeks for them to show up, Caroline opened an account. And how long did it take you, Caroline, to open an account?
Like 2 minutes.
Yeah, so in 2 minutes, after about 24 hours, your account would be fully activated. But within 15 minutes of you opening an account, you could buy 100 servers and have them launch simultaneously. So, that's very different than the real world, where you have to wait 6 to 8 weeks to get 100 servers if you're lucky, right? So, plus you can't give them back usually. So, Caroline, if she started 100 servers, she could just shut them off in 5 minutes.
First of all, I couldn't start 100 servers because I don't have the capital.
Well, that would cost you 3 cents to start.
Not through AWS, but I mean, I couldn't do it the other way, like literally.
You can order $116,000 servers. I think you could probably figure that out.
Yeah, I think I'm a no. I think it's not going to work out.
So this is what the promise of cloud computing is, that you don't have to spend money you don't have. So, and then remember the three models is that companies are typically all into cloud, all into their own hardware, or they're usually a mix, which is where a lot of the late adopters are now, is they're kind of mixed. They're like, hey, we already have our own hardware and we want to use the cloud.
Yeah.
And let's see, we talked about the ridiculousness of the number of services that are out there on the console. Like we just kind of like scrolled through them and it just like, it's overwhelming. It's overwhelming for me. And I've been doing this for 10 years. They just keep adding more. I'm like, just stop, just stop adding services, but whatever. There's like 6 key benefits Amazon wants you to remember. So basically you're trading hardware investment for variable expense. By the way, we know this because everybody does subscriptions now, right? We don't really pay flat fees for anything anymore. It's like we pay, $7 a month for our Instacart, subscription. So we don't pay the delivery fee. We don't pay, hey, I pay $100 and I've got this product. It's all subscription models. Even gaming, like on the phone and stuff is like all microtransactions, and we're used to variable expenses, which is kind of unfortunate. Because you're not spending your business dollars trying to run hardware, you can now just focus on what's important to the business. So that's, it's cost optimization, but it's also business optimization. And then, if Caroline wants 100 servers and then wants to give them back, she can actually stay ahead of capacity. So if she needs 50 on Friday and 100 on Saturday, she can do that and just give them back when she's done on Sunday. So it's, it's capacity. So the reason they can get away with that, by the way, is Amazon's hardware boundaries. Amazon owns, I think at last count, like 800,000 servers. They're scattered all over the data centers, right? And we're talking servers of size, so not tiny little systems. We're talking about, one of them I looked at had 448 CPUs in it and like 24 terabytes of memory, which is just, if that doesn't make any sense, let's just say this, it's like Godzilla large, and that was one of them. So they have a ridiculous amount of capacity. So you as the customer, being a user of their stuff, you don't have to worry about what the hardware boundaries are, because they are so far beyond what you're going to ask for, because they're feeding, 100,000, if not 1 million customers like you. So they've got huge footprints out there. So you can scale in and out as you need to and just give it back to them. They don't even care, as long as you paid for it. Oh, wow. That was the end button. That was not the button I wanted to hit. The other thing is that every time they get more efficient at doing their jobs, they pass the cost saving on to us, right? So instead of, robbing workers blind like Walmart, they just rob their warehouse workers blind. I'm just kidding. They probably do actually. And so what happens is that with their storage facility, as they get better at running storage, they just pass the savings on to us. So the cool thing about AWS is one, they're not affiliated with warehouse workers because they're a whole separate line of business. So they might suck in different ways, but they at least don't suck in an inhuman way. But the cool thing about this is that like they've lowered prices like 17 times on one of their services like in the last 10 years. So it just keeps going down. The other thing is just speed and agility, because right, you don't have to plug in hardware. You don't have to plug in hardware and figure out where it's going to live. You just get it and you go, right? And then like going global math. So reminder, Caroline could have actually started servers in Tokyo, Cape Town, South Africa, Sao Paulo, Brazil. She could have started servers within 15 minutes of her launching her account. So there's 28 global data centers all over the world. So the minute you get access to an account, you can start them anywhere. We talked about how they kind of group things into sections, which we looked at before in the console. So there's like compute sections and networking sections and database sections, and you don't really have to memorize those. So I guess they're just letting you know that they categorize things. And then we went through the knowledge check, which you both did through flying colors. So that was really impressive. You do better than most of my students, so it was good. And then we moved on to a pretty difficult topic, which is one of the 3 ways in which you can actually host like an application. Like, so for example, to kind of like step it down, to dumb it down a little bit. Let's say you wanted to take Word, like you wanted to run Word, right? And oh, did we lose you? Did you lose me?
I see her.
I think she lost sounds.
I did. Was that my computer? Okay.
Yeah, just want to make sure I saw your face.
Yeah, thank you.
Yeah.
Like, this is a new computer. I can't have broke it. Oh.
No, and that might be the internet, so it's probably not you. Yeah. Yeah. So we talked about like how virtual machines are the way that we've hosted applications like Word or web servers or email servers or any of the stuff. That's the way we've done it for like 20 years now. And so there's actually 2 other ways to host applications. One is called containers and the other is called serverless. And so those are the 3 ways we can host applications. They all have pros and cons. So what we talked about first was the one that we've been doing for 2 decades, which is virtual machines, right? And virtual machines, again, think of that like taking your laptop, digitizing the whole thing and stick it in the cloud. Now, obviously, there's different sizes of laptops, right? So if you think about that, what we're usually doing is that we're essentially lying to the laptop and saying that you have real hardware, but it really doesn't have real hardware. It thinks it has real hardware, but it's actually just all digital. It's just all fake hardware, right? And so that way the operating system, when it goes in and says, I have a hard drive, I'm so happy, it doesn't really have a hard drive. It has a fake hard drive. It's not real. So that's what a virtual machine really is. Now, this is where the information started to really kind of get intense and kind of big, right? Is that EC2 stands for Elastic Compute Cloud. And the idea here is that this is the virtual machine service. This is where you go when you need a virtual machine with an operating system. And when I say operating system, I mean Windows, Linux, or Apple's awesome little Mac OS, which is a real pain in the rear end to deal with. But most people in the enterprise are either going to run a Windows server version or a Linux server version. What's the difference? Windows is made by Microsoft. Linux is made by like 15 different companies and it's open source. Linux tends to not have a GUI, so there's no like windows to kind of click around in, whereas Windows, well, Windows has Windows because that's why we call it Windows. So
What does open source mean?
Sorry, say again.
Open source, what does that mean?
Oh, that's a good question. So open source, yeah, we should talk about that. No, not Rick and Morty. We're not going to talk about Rick and Morty.
Hey.
We'll talk about Rick and Morty later. Open source, or FOSS, free and open source. So free and open source basically is software that basically is given away freely. So I'll post this actually in the chat. This is the kind of Wikipedia version, but there is an open source group called GNU. And they are sponsored by the Free Software Association. So by the way, if you ever reach Stallman, this guy who wrote this thing, make sure you punch him right in the face because he's kind of a misogynistic asshole. But regardless, he actually, has shepherded some good ideas, including open source. But you should still punch him in the face when you see him. You can tell him it's from Michael Forrester. He knows who I am. So like free and open source software basically is where there are people out there who believe that knowledge and software should be freely available. So what they do is they take their spare time, and in their spare time, they basically they create software that we know and love. So Linux, as an example, it was created by a gentleman named Linus Torvalds, which he actually didn't name it after himself. He named it after something called Minix, which we'll talk about. So what happened is that he created this whole Linux operating, the kernel of like the core of an operating system, and people just went crazy and they were like, man, this thing is free. We love this thing. Instead, we hate Microsoft. So let's invest all of our community and free time into making this free software. And so what happens is that you literally have hundreds of thousands of free software out there that's all done by community contributors. So for example, some people don't like Office, which I think actually Office is a good product. Microsoft's Office, like Word and Excel and all that stuff. Well, there's a free version called LibreOffice, which means, free office, right? And so they, have, parroted some of the features that are in Office. And so they created their own open source projects. Now, open source typically has licensing that doesn't allow you to get paid for it. Now you might ask, well, why is this relevant? Well, Amazon likes to take open source projects, convert them into services, and then have people pay to use them. So they're not charging for the software, they're charging for the service. So for example, if there's a database called Postgres, for example, that is open source and people have spent, millions of hours investing in, Amazon will take that database, pull it into their system, wrap some service structure around it, and they'll offer it as a service and say, here you go. You can now get Postgres. And the reason this has worked is because they're not selling the software. They're basically saying you can have the service and you don't have to go through all the setup pain. It's like all of a sudden just being able to click on a web page and get access to Word, which is basically what Office 365 is, right? So it's the same concept. The only difference is that Microsoft stuff is all proprietary. They wrote it themselves from the ground up. And the open source world is like, our stuff is free. And so not only can you get this stuff for free, you can actually get the source code that makes it work, the stuff that literally builds it, you can get it for free as well. So these people believe in open source software. There are literally millions of people around the globe who contribute to various projects or whatever they're interested in. And so you can find free versions of almost everything.
That is crazy.
And it's not illegal. Like they're not doing anything wrong. They're not like trying to steal somebody else's business. They're literally just giving it away for no profit. So, typically they don't work as well as the closed source counterparts, but just so you know, Amazon has made a business of taking these open source products and turning them into services, which they make a lot of money off of, which has really ticked off a lot of the open source contributors. But that's what open source is. So let me post this in the chat. All right, so back to virtual machines, which are based, like on those operating systems, Windows proprietary, Linux, which is open source, but does have some companies behind it. And then Mac OS, which is super proprietary. Apple will sue you if you do anything with their operating system. So, that's just the way they are. All right, so we already talked about the client server model like we did before. Someone makes a request, you get a response. By the way, the customer's waiting. So think of this as a synchronous kind of like interaction, meaning I go to Caroline and say, hey, Caroline, can I have $1? She didn't answer. Can I have $1? See, and then I got a response, and then I'm like, okay, good. Transaction's done. She said no, right? We're done. If I come back here and well, can I have 50 cents? That's a new request. Can I have 50 cents? Can I have 50 cents?
You can have the whole dollar, Rishi.
And so now she just upgraded me to $1, but I got a response, and so now the transaction is done. So that's usually called synchronous. If it was like, hey, Caroline, I'd like $1. I want you to think about it. Let me know. And you walk away, that's an asynchronous response, meaning I'm not sitting there waiting, right? I'm waiting. She's going to let me know. She's going to send me a notification when she's ready, right? And what she'll do is she'll roll it up into a ball and throw $1 at me, and then I'll know that I got it. I'm just kidding, right? So that's a asynchronous, which means I'm not the person who made the request is not standing there waiting for the response to come back. They've left, So then you just have to talk to them and say, hey, you can have $1. So. All right. So the reason this is still relevant is that when and we'll get to this more and more, is that when you talk to AWS, it's going to be synchronous. Meaning you're going to say, I want a virtual machine. They're going to say, we're starting one right now. I would like to put a file out onto your storage system. Okay, good. We just stuck it out there. I'd like to start a database. We just started one for you. Right. So they're not going to leave you hanging where it's asynchronous. They're always going to get back to you. Okay, so we talked about virtual machines, and this is where we were saying, okay, we got virtual machines. We want to boot an operating system with certain characteristics. And then I think I showed you this really awesome and overwhelming website called ec2instances.info, which basically started listing all of these numbers for all of these characteristics that were like, whoa, whoa, Forrester. And if I remember correctly, I took some of you over here also to some AWS documentation so that we can actually literally look at all of the crazy types of virtual machines that you could get. And the main thing that you were to remember is there were 5 categories. There was general purpose. There was like compute optimized. There were memory optimized. There were GPUs, which are hidden under the codename accelerated computing. Why AWS? Why? Just call it GPU computing, regardless. They call it accelerated computing. And then there's storage optimized. So general purpose, compute optimized, memory optimized, let's say storage optimized, and then the last one is the crazy accelerated computing. And that's it. So these are these 5 purposes. By the way, nobody has these memorized off the top of their head. Even I know only like 10 of them, right? Nobody has these off the top of their head, and they change all the time. So you literally have to go look them up if you're looking for something special, right? You know, like someone might say, hey, I use the M series. And I'm like, hey, that's general purpose. M is for median, right? Great, I'll know that. But they'll be like, I used an M6 IT. And I'm like, sure, I don't know what an IT is. But 6 is probably the latest generation from I looked. And if I look on this documentation, notice there's nothing higher than 6. So that means 6 is the latest generation of the M series. The rest of these, like when they start throwing letters after the end of it, I got to go look them up. Typically, everybody does. Typically, you don't have that memorized. And they do actually mean significant things. Like, yeah, I'm not even gonna speculate on that. Let's just say they all mean. What is the I? They just added an I. What is an I? Oh God, why did they change the names of these things? Moving on. So anyway, so don't get all hung up in knowing all of the machines. And the reason that this site was here, this one with all the crazy numbers and all the stuff on it, is that sometimes we don't search for virtual machines based on Amazon's stupid names, because they are dumb. I just wish they just made it all the same letter. Just call it all the M series, but whatever. We don't always search on their stupid names. What we might do is that someone will come to you and say, hey, Caroline, I need a 16 gigabyte memory machine. And what you will say is, oh, cool.
Sure.
You want 16 gigs? So you come in here and you search for 16 gig machines and you're like, okay, do you know how many processors that you need? And they'll say, well, the vendor documentation says we need 8. And then what will happen is that you'll get a bunch of like options, but mainly it's going to be the compute instances, because you can see a bunch of C's here. See all the C's over here on the family names.
Mhm.
And so then what you're going to do is you're going to go switch over and go look at the documentation, right? Hey, what's a 6CG? Oh, that's a Gravitron processor. Are you guys okay with Gravitron processors? And they're like, no, we only use Intel. It's like, okay, well then we're going back to C5s, because C5, in other words, if what I just said didn't make sense, you're going to read the documentation and say, I'm going to pull these up. Is that okay? And whoever is making the request is typically going to give you the answer for what they're looking for. So don't get wrapped up in memorizing this documentation. The only thing you need to know is what the first letter stands for. C is for compute, R is for RAM or memory, M is for median, which means general purpose. If it says G on it, it's going to be a GPU system. And if it says a D or an I, it's going to be a storage system, right? So those are the things that you want to memorize, right? That's it. And by the way, those are all covered in the practice exams. So even if you didn't write that down, when I give you the practice exams at the end, so that you can actually, like, of our series together, you're going to get all that information thrown at you, so that you can, even if you haven't written it down, it's going to get reinforced. Okay. Because when we get done with this module, you're going to get a series of practice exams that I'm going to have you run through until you're sick of them. So that way, you know the knowledge like this. Okay. D's like, I don't think I like you so much anymore.
I like to write things down. It makes me feel safe.
Yeah, no, it's all good. Yeah, I think writing it down is also awesome. Like, don't stop. Keep going. Okay, so virtual machines, a ton of different flavors. We covered this already, right? And so the flavor just depends on what the person tells you that they need. We don't even get any wrapped up on the categories really that much. Now, what happens is that you launch an instance and then you have to remotely connect to it. So if you can visualize in your brain, you're in a physical location. Your virtual machines are starting in another physical location. So you're going to have to connect to that location, and you're going to have to see what's on the computer screen, which is weird, right? Because you've got computer screens right here, and you're going to go virtually connect to somebody else's screen and have it display on your screen. Because that's how we administer computers is we log into them remotely. And so we can see what they see, right? Or at least what they're presenting. Because even though they don't have monitors, they can like virtually present their monitors so we can actually see the innards of what the operating system is doing. So you connect to the instance. There's two different ways to do that. And then you can use the instance. So you can install software, you can restart it, you can do all kinds of stuff. Now, Amazon wants to remind you that, you know, there are these types that we were just talking about, right? Because they're designed for different things. The only thing that changes with these things is whether it's the ratio of memory to CPU. The only other thing that can change is if they add funky letters to the end of the name, that means they've probably added something special to it, like an extra hard drive or faster networking. Those are edge cases. Most people don't really care, right? Accelerated computing, remember, is code for GPUs, and then we've got the storage optimized instances. We just talked about this, right? All right. I think we all did that. And then we talked about pricing. Now, remember, this is where it gets weird. Because if we go back to that ec2instances.info site, remember that we had pricing over here on the right-hand side. Wasn't that weird? Let's talk about this for a second. So actually, let's put in a cheaper set of boxes because I think this is probably what most of us will end up using. Let's do the T3 series. I love the T3 series. These boxes, by the way, like this is a 32 gigabyte memory, 8 CPU system. I want you to see how much that costs at retail price. See that 33 cents an hour under Linux on demand? Right here.
Mm-hmm.
That's 33 cents an hour.
Big
So
spend,
say again?
big money.
Yeah, big money. Well, I mean, if you started 100 of these, it would cost you $33 an hour, right?
Yeah.
Right. That's my point. Is that that's the most expensive of these boxes, right? Notice these are all T3s. You can see over there in the API name, it says all T3s, T3.medium, T3.large, et cetera, et cetera. Notice that that's the most expensive of all these boxes, and it's 33 cents. So, you know, again, remember that if you keep this up for 24 hours a day, 30 days in a month, it's going to be about 730 hours, 722 hours or something like that. But that is the most expensive way to use Amazon. The reason is that see how it says on demand up top? Right above that price area, right? It says on demand.
Mm-hmm.
If we keep going over, there's also another type where it says reserved cost, right? So reserved basically means that, I know this sounds going to sound strange, but think of on demand as like dating. We're dating, right? Which means, you know, we're not exclusive, but we're dating, or we could be exclusive. That could be part of it. I don't know, but we're dating. We're hanging out, dating. But if I'm done with you, it's not going to cost me anything. Like I'm just like, yeah, it's not working out. We're done, right? Reserved is like a marriage, except you only do it in 1 year and 3 year chunks.
Yeah,
So
like never mind.
No, like a what?
Never mind.
No shots. Okay. So reserved is basically where D, are you frozen? I just want to make sure you can still hear me.
I can hear you. I just, there we go.
Yeah.
I'm with you.
Are you okay? Just making sure. Are you getting a low bandwidth thing on warning on your Zoom?
No, I don't.
Okay.
see any.
Okay, then we're good. Just making sure. So if your screen freezes, I might stop just to make sure you can hear me, or I'll check in and make sure you can hear me because I don't want you to miss anything.
Okay.
So reservations or reserved instances, that's like getting into a marriage. So for 1 to 3 years. So if you get into a relationship with Amazon and say, look, in exchange for me paying you for a year for this virtual machine, Amazon can give you somewhere between a 25 and 75% discount. So instead of paying 33 cents, you would knock 75% off of that, right? Now, obviously, the longer you commit, the more of a discount they give you, right? So if you go for 3 years, they're going to give you 75%. If you go for 1 year, you might get 40 or 50, right? Notice also that there's a spot price. So there's a third way that you can engage with these EC2 licenses. In other words, you can say, look, on demand, I just want to buy a virtual machine, and when I'm done with it, I want to give it back. If you're going to do Linux reserved, you would say, hey, you know what? I'm going to run this web server for a year. And Amazon, I know I'm going to run it for a year, so I need you to give me a 75% discount or 40% discount, 40, 50. And then they'll give it to you. And by the way, you're not like bound to this. You can actually sell those reservations. So it's not like you're tied into it, but Amazon, it's a little bit more of a commitment. Spot instances by comparison. So I want you to notice that over here, it's 33 cents for the on-demand cost. And over here, it's 0.099, which is basically, you get the math, right? It's 10 cents basically. Why is there such a difference between these two prices? Well, here's what this is. So Amazon has extra unused capacity. So imagine this. You're in their data center and they have 1,000 T3, like 4X larges. They have 1,000 of those boxes. But the on-demand customers and the reserve customers are only buying 500 of them. So they've got 500 servers just sitting there doing nothing, and they're paying for them, right? So what happens is that then the spot costs come in, is that spot represents Amazon's unused capacity. So so what happens is in exchange for giving you a discount, Amazon says you can have this, but here's the catch if you use spot. If a customer comes along and says, hey, I need 300 virtual machines, Amazon will give you a 2-minute warning and they're going to take away your virtual machine. 2-minute warning. So spot instances are not for things that you want to run consistently. Spot instances are for things like reporting or things that can be interrupted easily. And you could like start it back up later that don't really have a time dependency. So using virtual machines that are in spot mode is a very like specialized thing. But just know that they can give you up to a 90% discount on price, which is not nothing. That's pretty sizable, actually. And then notice, by the way, that also that the Windows cost and the Linux costs are different. So notice over here that the on-demand cost is 48 cents, and over here it's 33 cents for Linux. Here's why. It's the Microsoft tax. Amazon has to pay Microsoft to license Windows. Nobody has to pay them to license Linux because Linux is open source. Linux is free. Windows is owned by Microsoft. So if you want to use Windows, you got to pay Microsoft for the licensing. That's why there's a price difference. Most businesses are focusing more and more on using Linux because of the Microsoft tax. So just know almost every new business I know doesn't use Windows because it's more expensive. And in this case, if you look at the difference between 48 cents and 33 cents, I mean, that's almost a third higher. Is that right? Actually, that is a third higher. Yeah. So, all right.
Right.
So those are 3 core licensing types: on-demand, reservations, and spot. Now, if we go back, here's on-demand, here's spot, which we just talked about. Remember, spot is the extra capacity one. That one can go to 90%, but you can't forget this. If you decide to launch some spot instances and someone else comes along and pays on demand for those same boxes, Amazon's going to take those away from you. You get a 2-minute warning. So just remember that spot is specialized. On demand, by the way, use it, give it back. Remember, it's like the dating thing, right? It's like, or maybe it's more like Tinder. I don't know. I'm making up shit at this point. Reserved is definitely like a commitment, right? It's a 1 or 3 year commitment. You can't go beyond 3 years and you can't do less than a year, but it's either 1 or 3. So if there's a question like on your test or someone's like, hey, we're going to run this project for a year. It's like, would you like to buy reserved instances? Most of the time they're going to say yes. So the other thing that's a little weird is that like a bucket of good fried chicken, they decided to come up with compute savings plans. Now, I only say that because this is actually the example that's literally listed in my speaker notes. I guess the person who wrote this slide deck for Amazon really loves fried chicken. I mean, let's be clear, good human beings do. So compute savings plans, it's like good chicken wings. It's really about the sauce, but whatever. Compute savings plans. So what this is that this is where you go to Amazon, you say, hey, Amazon, I will give you $20,000 if you'll give me $25,000 worth of compute. So I will pay you now if you will give me a bucket of compute. And every time I run a virtual machine, it's just going to eat out of that bucket. So in other words, if the machine costs $1, it would actually only cost you 75 cents. You automatically get a 25% discount if you make your virtual machines consume out of this bucket of dollars that you've already prepaid Amazon for. I don't know who came up with this idea. It's only been around for a couple of years compared to the 15 years Amazon's been in existence. Whoever did this was a genius, because basically, like, it only lasts for a year, and actually it can last for 3 years. And typically it's 25% savings. It could go higher if you go to 3 years where you get up to 66%. But basically what happens is that you buy that bucket of compute, and then not only virtual machines, but if you decide to run containers or serverless, the other 2 types of application hosting that we talked about a little bit earlier, those are also compute functions. So they also eat out of the bucket. And so you get a discount off of everything. It's like, hey, Amazon, here's $20,000. And Amazon's like, great, you just prepaid us for a year's worth of stuff. Here's a 25% discount. So that's another way. It's not really a licensing model. It's just a way to save money with EC2. So Amazon wants you to know that that's an option, right? By the way, just like reservations, it has a 1 or 3 year commitment. And by the way, when I say 1 or 3 year commitment, if you buy $20,000 worth of stuff and you don't use it in a year, it expires, it's gone. Not cool, but that's what happens. So make sure, you use it within the time frame. And then the last thing is the weirdest kind of like 2 things that you could do with Amazon. They're also technically the most expensive things. Let's say that you work for the NSA, which I would question why you're even talking to Amazon, but whatever. Let's say you're talking to the NSA, and the NSA like obviously is very security minded, right? Especially after Snowden. So many comments, so much material, so little time. So let's say that you're like, I want to run my virtual machines on their own secure host. I don't want any other customers from any other Amazon customers. I don't want them on this host. So what you do is you buy a dedicated host, and then you get your own little like machine, like physical box that you can run all the virtual machines you want to, as long as that box has capacity. So that is the most expensive, and it's so expensive they actually don't list it on their website, so nobody knows unless you've done it how much it costs. They also put you under NDA, but you basically get a physical machine inside of Amazon's data center. And so they've got dedicated hosts and they got dedicated instances, which basically just do the same thing. They increase security for your virtual machines. Most people don't do this. I'm just going to tell you right now, most people do not do this, but you got to know if you need increased security, this is an option. The reason I say most people don't do this is that if they want that, they usually just contract with Amazon to build their own private, like just to say this, AWS has built a private cloud for the CIA that nobody gets to see or look at. And even the AWS employees didn't get to touch it. They just got to tell the CIA how to build it. So people with security minded are probably not going to go this route, but whatever, it's here. Let's see. Oh, that's pretty good information. Kind of wish that was on the slide, actually. So they were asking like what the difference is between saving plans and spot instances. Saving plans is a bucket of compute. You got 1 to 3 years, consistent amount of usage. Spot instances are those flexible 2-minute, workloads, right? Okay, so that was all virtual machines. And what we're going to talk about next were the enhancements to the virtual machine. So autoscaling was just a way to add and decrease the number of virtual machines that are in a pool of virtual machines. So for example, on low demand, you only got 2 customers and 1 barista, but at a high demand, you might have 2 baristas. So
in this case, baristas are servers.
in this case, they're servers, right? So let's say that for some reason you get a wild hair and decide to create a foot fetish site, and you go from 1,000 users to 10,000 users, right? And then what happens is that you might need to increase the number of web servers that you have, because all of a sudden someone's beautiful foot's out there in rainbow heels, and it's like, and you want to make money, so you decide to scale your web servers. This is where like auto scaling kind of really comes into play, because it allows you to add more servers as demand comes in, and then it allows you to shrink the servers when you don't need them anymore, because demand, that's how it works. Yeah. So Amazon will do this for you if you actually set it up. So they'll actually stay ahead of customer demand by adding capacity just ahead of demand. So like, if all of a sudden you go from 10,000 users to 50,000, it will add the number of servers you need, and it will do it for you automatically. You don't have to wake up at 3 o'clock in the morning and deal with it. It just does it, right? So this is a pretty cool feature. This is actually the thing I think that makes Amazon like really cost effective from a virtual machine perspective. And it really changed the game when they came out with this. This was like 10 years ago. Now, don't get me wrong. You can actually set your minimum number of servers. Like if you always want to have 2 at any given time, or you can set your max. Like maybe your max is 1,000 because you don't want to pay more than $33,000 an hour. Let that sink in for a second. So if you're like, running $1 servers, or maybe it's 100, maybe it's 50. So you get to set your mins and maxes. So the auto scaling like machine is not going to go beyond your boundaries. And you might say, well, Michael, wouldn't I just let it go all the way to whatever max it can support? No, because what if some spammer gets a hold of your website and creates a bunch of fake traffic? They may not knock you offline, but they could cost you $33,000 an hour. So you got to be careful with what you set the maxes to, right? That has happened, by the way. There was a guy, a security researcher, who was being hosted by Microsoft, and he was so good at his job that he was constantly getting attacked online. His website was, that people were trying to deface it and stuff. It cost Microsoft $2 million a year to defend the guy's website. But then they kicked him out, but he does such a good job for the community. Google picked him up and hosted him for free. And they were like, we don't mind spending $2 million on this guy. So anyway, so that's auto scaling. Allows you to elastically add more servers and remove servers automatically. All you have to do is set it up, fire and forget, let it run. Now, in order for that to work, you can't just have 15 web servers, then go to 30, and then the user's like, what do I type into my web browser to get to your website? Right? What ends up happening is that you need a single point of contact into those like 15, 30, 100, 10,000 servers. That's what a load balancer is. A load balancer is a single point of network contact that will allow you to take, like, for example, www.fabulousfootfetish.com, resolve it to no, I didn't buy that. I'm just throwing it out there. Fabulousfootfetish.com. It points to a load balancer. And what happens is the load balancer is a device that takes the traffic. So in this case, the workload's unbalanced, and here the workload is balanced, meaning that all of the servers would get distributed traffic for, fabulousfootfetish.com. So that's what a load balancer does, is its job is to make sure that any servers that you add into the pool of servers, like if you go from 15 to 30, is to make sure that the new 15 all get a distribution of traffic. That way the user doesn't care if you have 2 web servers or 1,000, they actually don't see it. They type in www.fabulousfootfetish.com, they go to the load balancer takes care of where everything goes. And if you want to add servers and remove servers, that's what a load balancer does, is it takes care of all that for you, right? You just turn the dial. Hey, I want to go down to 10. I want to go up to 1,000. And the customer never really knows what's going on. All they know is that the website's up because there's at least one server up. So think of this as an entry point into a pool of servers. That's what this device is for. Now, as you can see here, there's a low demand period where there's 2 customers at the top, and notice there's only 2 servers in that auto scaling group hitting that load balancer. Now, if we look over on the right, we now have basically 2.5 times the traffic because we've got 5 customers. And notice that we've doubled the number of web servers. We've gone from 2 Amazon EC2 instances. Those are what they call virtual machines. They call them instances. And now we've got 4 virtual machines. Who did that? Well, the auto scaling group did. So the auto scaling group and the load balancer talk to each other. And what happens is the load balancer is like, holy shit. It doesn't actually say that, just in my mind, it says that. It says, holy shit, we just got 10,000 more users. And the auto scaling group goes, well, the person who created me said I could grow up to 1,000 servers. So why don't we add 100 and see what happens? And when it adds 100, the load balancer is like, whoo, you know what? That foot fetish site is down to really quick speeds, so we don't need to add more servers, right? Or it says, oh my God, we're not loading our feet correctly. Auto scaling group, help me out. And the auto scaling group's like, let's just add another 100 servers. And it will keep doing that up to your maximum, or until customers are getting the responses that they want at the speeds that they want. By the way, you get to set all of that. Now, you both may be aware of this, but if a website takes 5 seconds to load, in this day and age, people will abandon that web page quickly. It doesn't even matter how old you are. But as you get younger in age, like down to like 30s, 20s, teens, people will not wait 5 seconds. Matter of fact, 20-year-olds and teens will typically abandon a page that doesn't load in less than 2 seconds. And they'll never go back to it usually. Just depends on what it is, right? So they have all these charts on abandonment rates that show, like, if a page doesn't load in a certain amount of time, people are out of there, right? So that kind of user experience is what auto scaling and load balancers are meant to solve, is to make sure that like if it's a web page, for an example, that it always loads crisp. And if it starts slowing down, add more servers to give more horsepower to the web server, like to the web page, and then everything starts loading up fast again, right? And then, by the way, if it's like, 6 a.m. on a Sunday and nobody's looking at your website, it'll scale the servers down because load is low, right? There's no demand. So that's elastic load balancing. So auto scaling's job is to add or remove servers. Elastic Load Balancing's job is to distribute traffic to those servers. The two of them talk to each other and work together. Any questions about that? Because we're kind of in new material here, right? We haven't covered this actually. Because Caroline and Dee, we only covered the EC2 virtual machines last time. We didn't actually talk about this in detail.
No, I think this part makes sense. Like,
Cool. Good. Wow. It sounds like you have the knack. What's that old Dilbert cartoon? The knack. Is he going to be normal? It's like, no, he's an engineer. Anyway, moving on. All right. So then here's the question. Here's a little knowledge check. Are these examples of auto scaling, like where you're going to add and remove virtual machines? Or is this an example of load balancing where you're distributing traffic to the network traffic to the virtual machines? So number one is like removing unneeded Amazon EC2 instances when demand is low. Is that auto scaling or is that traffic distribution through ELBs?
Auto scaling.
Auto scaling. Good. Love hearing that. That's accurate because it is involving virtual machines, right? All right. Number two, adding a second EC2 instance during an online store's popular sale. What do you think?
Yeah, auto scaling.
We're still adding virtual machines, right? So that's probably accurate. All right. What about distributing a network workload across several EC2 instances?
Elastic load balancing.
Right? Because now we're into network traffic. So that makes sense because that's what a load balancer does, is distributes network traffic workload. What about ensuring that no single EC2 instance has to carry the full workload on its own?
Elastic load balancing.
Yep, that's right. Because we're still talking about network traffic. Okay. Automatically adjusting the number of EC2 virtual machine instances to match demand.
Auto scaling.
Auto scaling.
That's right. Hold on 1 second. Are you over there popping a beer? Or is that a Zevia? Yeah, I'm talking to you. Oh, wow. 14 years old. You're too young to be that corrupted. Anyway, he's just getting a soda. He just got home from school. It's like his daily ritual. All right, providing a single point of contact for traffic into an auto scaling group. I feel like they kind of softballed that one up, right? Are we really that dumb that if it contains the other thing that we wouldn't choose the other thing?
Right.
No. I don't know. I might have to write them about that. They should update those slides. Okay. All right, so this all made sense because this was all about virtual machines or things that help virtual machines, right? Either something that distributes traffic to them or expands them. Now, I don't know who wrote these slides. It wasn't me, but I would take responsibility if I did. And I liked it that they're about to they like to have some variety in these slides, but we're about to take a little interesting little side trip here for a second that isn't really about virtual machines, but is about other Amazon services. So, you know, just be prepared. We're about to talk about, so if you've like created a mind palace and you've got a room that says virtual machines, you probably want to back out of that room, back into the central area, because you're about to walk into another room on a completely different subject. Okay, so.
Mind palace.
Yeah, you know, mind palaces, you know, like from memory, no. Sherlock Holmes, no, okay, move on. All right, so now we're going to talk about messaging services. And what I'm really saying here is that we're actually talking about a new AWS service. I don't know why, but we are. So one thing to know is that there's these buzzwords floating around where people are writing applications. They're like coding them with their tiny little coding hands.
Yeah.
Yeah. So they're writing applications, and usually there's some kind of mastermind behind the whole thing who's like, oh, are we going to have a bunch of people write a massive application, or are we going to have different people work on different parts and they can all be released and kind of managed and all that independently, right? So for example, there's probably a different team that works on Facebook Messenger versus like Facebook versus Instagram versus WhatsApp, right? Because, well, not only were those separate companies, but there's probably different teams of individuals. But together, there's some integration between those components, right? Because you can post on Instagram and it will post on Facebook, right? So, you know, what happened is that we kind of went from this whole thing where we were writing one big application till we went to microservices, where now things are kind of like more integrated. And so microservices are kind of where people go now, is that they try to create really smaller, but yet more tightly integrated applications. and they'll have a separate team work on it. So there's a whole separate team that works on Facebook Messenger, separate from, ads in Facebook or posts in Facebook. There's a, whole separate teams. So that microservices architecture is really like popular now. And notice that instead of all being on one virtual machine, each of these things would be on their own separate virtual machines. So instead of all sitting in the same memory space, now with microservices, everybody's talking to everybody else across the network. Now, the cool thing about that is that now we can release things independently. So component one can just release versions of itself as it sees fit. But here's the problem. As you well know, with our Zoom calls alone, networks are fragile. So now we've got to bake in a bunch of extra component like code and logic to handle like what happens when the network stops responding. Because you don't want the customer to have a bad experience, but you have to throw in a bunch of other things. So microservices are kind of the new ways in which we develop applications, but because we're now running across the network and distributed computing is hard, because that's what that is, it's distributed computing. Now we've added a whole slew of other problems. So Amazon wants you to tee this up because they've got 2 services that can help you solve some of these problems of distribution. Keep that in mind when I said that. So one is called the Simple Notification Service. Now, this is pretty much like an email subscription list, meaning you create a topic. Let's say, warts on toes, because we're still sticking with the foot fetish thing and some people are into warts, and let's just go with that, right? Is that true, by the way? Or did I just make that up? Anyway.
Probably.
God, it's probably true.
Somebody's into everything. Rule 34.
Thank you. Okay. So you create a topic. Let's say it's, warty toes, right? What happens is that people would then subscribe to that topic. And when you publish the message, God, I miss Nancy. Does anyone know about Nancy? Does anyone know about Divya's weird named blister that she had?
Yes.
You should ask her about Nancy and say, hey, Rishi told me that he really misses Nancy.
Okay.
Moving on, because it was such a weird period of time. It was awesome though. Is that so people subscribe, and let's say Divya publishes a picture of her blistery toe on warty toes, because maybe it's affiliated. Well, what happened is that all the people who are subscribed to that topic would immediately get a message. So it's consensual, meaning someone has come in and subscribed to the topic. And so by subscribing to the topic, they agree to receive messages that are published against the topic, right? No different than the email spam that we get now, except some of it seems to be non-consensual, but
So non-consensual.
yeah. But most of the time you get stuff from like sites that you've actually gone and signed up for, right? Yeah. So in that way, this is exactly how this works. The only difference is that it doesn't just have to be email subscriptions. It could be all kinds of subscriptions. It could be, your phone could be subscribed. Like it could be text subscriptions, like what they call SMS or text, right? It could be another website could be subscribed to your topic. And so when you publish a message, it would actually hit the other website. So there's all kinds of like subscriber types that are here for these topics, but that's what the Simple Notification Service does. So like, for example, let's say that in our coffee shop example, you want to publish out, trivia or whatever. You could actually create 3 different topics, and you could actually have it published to different people based on who subscribed to the topics, right? It's just up to you. So that's what the Simple Notification Service does, is it allows people to subscribe, and then they will receive messages about the topic. Now, I'm really kind of simplifying that because it's a really powerful service, but that's basically what it's used for, is people mainly use it to send email or text.
Okay.
So that's the Simple Notification Service. So its job is to notify. That's what it does. Now, contrast that with its cousin called the Simple Queuing Service, or SQS for short. So if you see the words SNS, they're talking about the Simple Notification Service. If you see the words SQS, they're talking about the Simple Queue Service. Now, these actually were named intuitively. This is a queuing service. You know what a queue does? A queue holds things until somebody else comes and picks it up, right? So if, like I remember working in the restaurant industry, and we had an order queue, right? So tickets would come in and we would put them on the line, depending on where you were working. I don't know why my nose is itching, but suddenly it is. Is that we put queues on the line, and we would pull the next line item off the queue, right? And we would work that order. Sometimes we would work orders simultaneously. We would pull them off into another section, but we'd have a queue, a backlog, if you will, of items that we were working on in food, right? This is the way most places work. I've seen it at Chick-fil-A. I've seen it everywhere. So the simple queuing service, its job is to simply receive those tickets and then somebody else comes and works the tickets. That's what it does. That's all it is. It's literally a tiny little ticket message. And there could be 100,000 of these things, which would be horrible, by the way, for the restaurant industry, but probably good for computing. And what will happen is that someone produces the messages, puts them on the queue, and then a number of consumers come behind and they just start eating off the queue. I got this ticket, I processed it, I'm done. Ticket number 2, I got this ticket, I'm processed, I'm done. And so you could have, 100,000 tickets and 10,000 servers who are all talking to this queue, and they're just pulling tickets out and processing them one at a time. That's what the simple queuing service does. So imagine you're Amazon and 500,000 people just placing an order for a bar of soap. Instead of making the web server deal with that, what they do is they tell the web server that just received that order, just put a ticket on the queue for soap. And then what happens is that the order fulfillment servers on the back end, they go and look at that queue and they're like, oh, wait, we have 500,000 orders of soap. Let's start processing. And so they start pulling, hey, this is Dee, we're going to send her some soap. Caroline, we're going to send her some soap. Michael needs some soap. Liam needs some soap. Divya needs some soap. Great. We just are going to send it on, right? And so they just process the orders one at a time. And every time they're done with an order, they go back and grab another one. So here's the coffee example. Customer orders, customer goes into a queue after they've paid, by the way. And then what happens is the barista gets the queued order. And then once they get to that person's order, they make the drink and then they pass it on to them. We're familiar with that, right? That's the way most of our transactions work. They're not synchronous. Like when we go to a coffee shop, we're like, hey, there's like 5 orders ahead of us. And so we're number 6. And so they'll get to us when they get to number 6, which, I think we're used to that. That's what a queue is. That's all it is. The order goes into a queue, barista picks it up from the queue, makes the drink, sends it to us. So we're familiar with the concept. That's all this service does, is that an application sticks a ticket on the queue and another application reads it. Now, the reason this is scalable, or why Amazon wants to mention this, is that you could literally, like I said, I think the cap is like 3 million. You could stick 3 million tickets on that queue before it would start running out of space. So it's pretty cool. So SNS, the notification service we were talking about before, and this service, which is SQS, they are like sisters of each other. They're like cousins. One pushes messages out to people who have subscribed. The other one requires you to pull the message. So you have to go to the trough and like pull the queue message out. So one pushes to you and one forces you to go after it and pull it. So these are called push-pull methodologies, right? And these are just ways of passing messages around. That's all they are. So SNS does a push, SQS does a pull. Okay.
Gotcha. I'm with you.
Yeah. All right. Now we're going to switch to one of the other ways of application hosting, but we've only got 3 minutes left before we need to stop. So let me just take a quick look here. We got Lambda, we've got containers. So that's the other way of doing message hosting. And then we're into knowledge check. So perfect. Okay. So that works out well, actually. So we're going to talk about the other 2 application hosting methodologies, which is containers, and Lambda, which is serverless is actually the name of it. Lambda is the name of AWS's service. The category is called serverless. It's called serverless. The middle category is called containers. The bottom category is virtual machines, which is what we talked about before. So we're going to talk about those last 2 services the next time we meet, and then we're going to roll into, oh God, what is the next thing? Actually, hold on, I just forgot. Oh, we're going to talk about where Amazon puts all the data. We're going to talk about Amazon's physical infrastructure, like where they stick these virtual machines and where they stick all the data. So does anyone have any questions for me? Did we talk about anything that needs to be clarified or didn't really stick, or anything that we need to take a look at?
No, I think I'm good, actually.
Let me show you just this one thing. So there's a website, aws.training, which I know we've talked about before. And out here is, if you sign in, remember it's always the sign in on the left. If you sign in and let's see. What will happen is if you come out here, and I think I sent a link out this before, but I can repost it. Actually, I'll repost it here in a second. If you search for Cloud Practitioner, which is the training that we're doing basically, and you go for digital training only, which is this little piece up here, you can actually find the literal class that we're actually doing. And actually, I'll post this back out just for those who want it again. And so what will happen is if you click on resume, it'll actually load up the class. Now, the reason I'm sharing this is that, I'm going to share obviously the video on our video link. But if we come over here and you look at the modules that I literally just talked about are over here on the left-hand side. So if you're like, hey, can we talk about messaging and queuing again, Michael? Because I didn't quite get that. Here's a video that will literally go back through the same thing I just talked about, including the slides. This is the entire training that we're going to go through. So just know that this is here. If at any point in time you either want to go back through it, you want to get ahead, I have no problem with you getting ahead of me on this and then just us re-reviewing it to make sure that we're driving it home. If you want to just wait until I'm the one who talks about it, I don't have an issue with that either, right? But just know that everything I talked about, including some more examples, will always be out here for you to look at, including the quiz questions or the knowledge check questions. Yeah. So, cool.
Yes.
Good. All right. So that being said, when would we like to meet again?
I work from home, so with the exception of my toilet exploding, I'm pretty much open.
Do you
This
have any?
time works for me. Don't you work till 3, right, Rishi?
Yeah. So typically I work at like 3 to 4. So like next week, it's all just 3 o'clock. So we can meet on Tuesday if you want to. We can meet on Thursday if you want to. I'm not the tie. We can work at whatever cadence you're interested in.
Time Thursday at 4 would be great for me.
Yeah, I think that works for me. Let me just pull out my book.
Okay. Oh my
It's
God.
a great name for a website, by the way.
Fabulousfootfetish.com.
That is great.
Yeah, 4 o'clock works for me next week.
Okay. Well, then I can fix that right now because let's see. Let's duplicate this thing.
You're gonna buy the foot fetish website URL. Is that what you're doing right now?
No, I'm updating our thing, but I can. Let's see. Hold on.
Yeah, they're funny.
What is the name? Oh, Namecheap. That's right. Let's see. Fabulousfootfetish.com.
It can't possibly not already be taken. Everything's already taken.
No, you'd be surprised.
Isn't there a dot porn now?
I want you to know that fabulousfootfetish.com is literally available for $10 a year.
That's hilarious.
Oh wow. Well,
I'm so impressed right now.
As well as .net, .org, .ai, .me, whatever. So should I buy that and gift it for, for
Towards the cause there.
hey, I better grab it now that I've searched for it. You'd be shocked that people will go out there and snag it because I've searched for it. So I better probably grab it now. That's hilarious.
That is hilarious.
is that gonna show up under like when people go like who owns this? Is it gonna come back to Michael Forrester?
No, because I have domain privacy enabled. Yeah, because that's, it's a thing, right?
Just
So.
saying, professional life to consider.
That is true. Yeah, we don't want to put you out there like that.
What? What? I think they could probably find weirder things.
I think you should say, yeah, I post pictures of my feet to make a little extra cash. Times are tough.
And there are worse things you could be posting of yourself to make cash. That's all I'm saying. Like,
Times are
it's not-
tough.
Times are
Yeah,
tough.
it's not like fabulousglons.com or fabulousfrenulum.com, like it's not. See, that could
Yeah,
get,
pictures of your friend.
but in various states of dress, tuxedo frenulum,
Oh my God.
know,
Little mustache friend.
Superman mustache, Wild West frenulum. I'm just saying, like
You run around with a whole dick pic there's a whole dick pic contest that was proposed here.
Kalamadas has a big mouth, so I probably did hear about it, honestly.
Oh,
So,
okay, you did.
Yeah. So, yeah, I think I'm gonna go ahead and grab this, and hey, if I get fired or kidnapped, you guys will know.
It was about your feet.
It was about my feet. Fabulousfootfetish.com.
Okay.
Wow, that could be weird. Do I really want to associate this? Oh God. You know what? I'll get back to this. All right.
Okay.
So we're all set for next Thursday at 4 o'clock. Otherwise, if anything comes up, just let me know. We are about, let's see. We're about a little, like maybe 20% done. So, and if we need to accelerate things or whatever, just know that these next 5 weeks, I'm typically only teaching till 3 o'clock. And so I usually have gaps in the afternoon. But I think the pacing we've got is pretty good, I think, for people's lives right now. No?
I think so.
Okay. So let's just text everybody if you want to change that. Otherwise, we'll just meet next Thursday and we'll go from there.
Okay.
Cool. All right. It's good to see you both. We'll talk more next time. I gotta go torture my son.
Okay, thank you.
Bye.
All right.
Have
See ya.
fun.
Thanks.